Welcome to the course. I'm James, and I'll be your host as we explore the artificial intelligence functionality available via the Openai API. In this course, you'll learn how to use the AI models available through the Openai API to solve a wide range of real-world tasks. To do this, we'll be using Python code throughout the course, and expect familiarity with a few Python programming topics, like subsetting lists and dictionaries, control flow, and looping. However, no experience with AI or machine learning is required. With that, let's dive right in. OpenAI is a company that researches and develops artificial intelligence systems. One of their most famous developments is ChatGPT, which is an application that allows users to communicate with an AI-powered chatbot, to ask questions, perform tasks, or generate content. The OpenAI API allows individuals or organizations to access and customize any of the models developed and released by OpenAI. If OpenAI was a car manufacturer, ChatGPT would be their shiny new sports car that people can walk into a dealership and test drive. The OpenAI API would be like the system customers could use to customize and order any car from the manufacturer's catalog. So what actually is an API? API stands for Application Programming Interface, and they act as a messenger between software applications, taking a request to a system and receiving a response containing data or services. An API is like a waiter in a restaurant. They take our order or request, communicate it to the kitchen, the system providing the service, and finally deliver the food or response from the system back to our table. Many applications interact using APIs. For example, a mobile weather app may send our location to an API and request the local forecast, which gets returned back to our phones. We can similarly write code to interact with the OpenAI API and request the use of one of their models. Our request in this case will specify which model we want, the data that we want the model to use, and any other parameters to customize the model's behavior. The response containing the model result is then returned back to us. Some of OpenAI's models, such as ChatGPT, can be used from the web browser. So what's the benefits of accessing them via the API? If we're looking to streamline our individual workflows using AI, then a low setup web browser experience is likely sufficient for our purposes. However, if we're looking to begin integrating AI into our products, customer experiences, or business processes, we'll need the flexibility of working with the API using a programming language. The beauty of making these models available via an API is that software engineers, developers, or anyone else wanting to integrate AI into products and services can now access and implement these models without needing a background in data science or machine learning. The OpenAI API has enabled the development of powerful new features that before would have required enormous computational resources and data. In the example shown from DataCamp Workspace, we developed a feature where users can write or fix code by providing an instruction, all built on the OpenAI API. AI-powered products and services can provide much greater personalization to customers, so experiences can be tailored to an individual's needs and preferences. Time to test your... Welcome back. In this video, you'll learn to make your very first request to the OpenAI API. Recall that we can request the use of a model from OpenAI by making a request to their API. Depending on the model or services required, APIs have different access points for users. These access points are called endpoints. Endpoints are a lot like doors in a hospital. Depending on the treatment required, patients use different doors to reach different departments. API endpoints, like many hospital departments, may also require authentication before accessing services. API authentication is usually in the form of providing a unique key containing a random assortment of characters. It's important to note that many APIs, including the OpenAI API, have costs associated with using their services. For OpenAI, these costs are dependent on the model requested and on the size of the model input and output. A crucial part of working with APIs is navigating API documentation, which provides details on which endpoints to use, their functionality, and how to set up authentication. Throughout the course, we'll provide these API details, but we also recommend checking out OpenAI's excellent API documentation. Usage of OpenAI's API requires authentication, so to use the API and complete the exercises in this course, you'll need to set up an account. OpenAI often provides free trial credit to new users, which will be more than sufficient for completing this course. However, for some countries, you may need to add credit. Then, for authentication, you'll need to create a secret key and copy it. DataCamp doesn't store any API keys used in this course, so you can copy it directly into the exercises. Let's make our first API request. There are several ways to interact with an API, but in this course, we'll use OpenAI's own Python library due to its friendlier syntax. We assign our API key to OpenAI.API-key, which is used to authenticate our request. Now for the request code. We create a request to the completions endpoint, which is used for completing a text prompt, by calling the create method on OpenAI.completion. Inside this method, we specify the model and the prompt to send to it. We'll discuss prompts in greater detail later in the course. Let's take a look at the API response. The API returns a JSON response. JSON stands for JavaScript Object Notation. It's a nested data format that resembles a Python dictionary with keys and values. The response has several keys, choices at the top, and created, ID, model, and others at the bottom. We can see that the text response to our prompt is nested inside the choices key. Let's start to unnest this object by selecting the value from that key. Recall that we can extract the value from a dictionary key using square brackets. This returns another nested object, but we've gotten much closer to the text. Notice from the square brackets at the beginning and end that this is actually a list with a single element. Let's extract the first element to dig further. Okay, now we're left with a standard dictionary, and our text response is located under the text key. Let's use dictionary subsetting once more. There we have it, our text response as a string. We started off with a complex object, but by applying our Python programming fundamentals, we were able to get there one step at a time. Time to practice making your own request. Great work so far. Despite being renowned for its GPT series of chat models, OpenAI hosts a diverse array of models capable of performing many different tasks. In this course, we'll be focusing primarily on OpenAI's text-based models. But later in the course, we'll also take a look at the audio transcription and translation capabilities of the Whisper model. For now, however, let's take a closer look at the text capabilities available through the API. The completions endpoint allows users to send a prompt and receive a model-generated response that attempts to complete the prompt in a likely and consistent way. Completions is used for so-called single-turn tasks, as there's a single prompt and response. However, the models available via this endpoint are extremely flexible and are capable of answering questions, performing classification tasks, determining text sentiment, explaining complex topics, and much more. The completions endpoint is available via the OpenAI completion class. The chat endpoint can be used for applications that require multi-turn tasks, including assisting with ideation, customer support questions, personalized tutoring, translating languages, and writing code. Chat models also perform well on single-turn tasks, so many applications are built on top of chat models for flexibility. The OpenAI package provides the chat completion class for accessing the chat endpoint, but we'll cover how to use chat later in the course. The moderation endpoint is used to check whether content violates OpenAI's usage policies, such as inciting violence or promoting hate speech. The sensitivity of the model to different types of violations can be customized for specific use cases that may require stricter or more lenient moderation. For business use cases with frequent requests to the API, it's important to manage usage across the business. Setting up an organization for the API allows for better management of access, billing, and usage limits to the API. Users can be part of multiple organizations and attribute requests to specific organizations for billing. To attribute a request to a specific organization, we only need to add one line of code. Like the API key, the organization ID can be set before the request. API rate limits are another key consideration for companies building features on the OpenAI API. Rate limits are a cap on the frequency and size of API requests. They are put in place to ensure fair access to the API, prevent misuse, and also manage the infrastructure that supports the API. For many cases, this may not be an issue, but if a feature is exposed to a large user base, or the requests require generating large bodies of content, they could be at risk of hitting the rate limits. Much of this risk can be mitigated by, instead of running multiple features under the same organization, having separate organizations for each business unit or product feature, depending on the number of features built on the OpenAI API. In this example, we've created separate OpenAI organizations for 3 different AI-powered features: a customer service chatbot, a content recommendation system, and a video transcript generator. This distributes the requests to reduce the risk of hitting the rate limit. It also removes the single failure point, so an issue to one organization, such as a billing issue, will only result in the failure of a single feature. Product-separated organizations also provides more granular insights into usage and billing. In this chapter, we'll take a deeper dive into the rich text and chat functionality the API has to offer. So far, we've used the completions endpoint to answer questions, but the model's capabilities go far beyond this. To understand where these capabilities come from, let's take a step back and discuss how text completion works. When we send a prompt to the completions endpoint, the model returns the text that it believes is most likely to complete the prompt, which it infers based on the data the model was developed on. If we send "life is like a box of chocolates" to the model, it correctly completes the quote with high probability. We say high probability here because the model results are non-deterministic, so the model may only correctly complete the quote 98 times out of 100. There are many use cases where randomness is undesirable. Think of a customer service chatbot. We wouldn't want the chatbot to provide different guidance to customers with the same issue. However, we would like the model to be flexible to different inputs, so there's often a trade-off in the amount of randomness. We can control the amount of randomness in the response using the temperature parameter. Temperature is set to 1 by default, but can range from 0 to 2, where 0 is almost entirely deterministic and 2 is extremely random. If we add a temperature of 2 here, we can see the model completes the prompt by putting its own bizarre spin on Forrest Gump's famous quote. Because the text completion model returns the most likely text to follow the prompt, it can be used to solve a number of tasks besides answering questions, including text content generation and transformation. Text transformation involves changing text based on an instruction. Examples include find and replace, summarization, and copy editing. For example, we can use the API to update the name, pronouns, and job title in a bio. Notice that the prompt starts with the instruction, then the text to transform. We've also used triple quotes to define a multi-line prompt for ease of readability and processing. Then, as before, we send this prompt to the completions endpoint of the API using completion.create. Voila! We have our updated text. Even with a find and replace tool, this task would normally require us to specify every word to update. Text completions are also used to generate new text content from a prompt providing an instruction. For example, we can create a request to generate a tagline for a new hot dog stand. The API does a good job, and even includes a subtle pun. By default, the response from the API is quite short, which may be unsuitable for many use cases. The max tokens parameter can be used to control the maximum length of the response. Tokens are a unit of one or more characters used by language models to understand and interpret text. In English, one token translates to about 4 characters, and 100 tokens to 75 words. So if our use case requires no more than around 150 words, a max tokens of 200 would be a good choice. Increasing max tokens will likely also increase the usage cost for each request. Recall that the usage costs are dependent on the model used and the amount of generated text. Each model is actually priced based upon the cost per 1,000 tokens, where input tokens, the tokens used in the prompt, and output tokens, the generated text, can be priced differently. When scoping the potential cost of a new AI feature, the first step is often a back-of-the-envelope calculation to determine the cost per unit time. Onward to the So we've seen that the chat completions models are pretty flexible and can do much more than answer questions. In this lesson, we'll take this a step further to discuss classification tasks. Classification tasks involve assigning a label to a piece of information. This can be identification, such as identifying the language used in a piece of text, categorization, such as sorting geographical locations into countries and US states, or even classifying a statement's sentiment, that is, whether it sounds positive or negative. The completions endpoint can be used for all of these tasks, providing the model has sufficient knowledge of the subject area and that the prompt contains the necessary context. Let's use the completions endpoint to categorize these animals. Printing the response, we see that the model categorized the animals into mammals, fish, and reptiles. This might be what we were looking for, but there's an almost infinite number of ways to categorize something, so it's best practice to state the desired categories in the prompt. We can update the prompt to categorize animals into those with and without fur, and the model responds with the desired categories. Let's look at an example of classifying sentiment. Let's say we received a number of online reviews to our restaurant, and we want to extract the sentiment as numbers 1 to 5 for further analysis. We can write a prompt with the instruction to classify sentiment and a list of statements, pass it to the completions endpoint, and print the response. The model has done a good job. However, because we didn't specify how to classify the categories, the model didn't realize we actually wanted a numerical output. We can update our prompt so the model has the context on what the category should be. The updated response contains a reasonable numerical representation of the sentiment of each statement. The prompts we've used so far are examples of so-called zero-shot prompts, where we haven't provided any examples in the prompt for the model to learn from. For many use cases, this may be fine, but for more complex cases, where the model may not have a good understanding of the subject matter or task, we may need to provide examples for it to learn from. If one example is provided in the prompt, it's called one-shot prompting, and for more than one, it's called few-shot prompting. Providing examples in the prompt for the model to learn from is called in-context learning, as the model is learning from the context we're providing. Let's return to sentiment analysis to give these prompting techniques a go. We're again dealing with the restaurant reviews, but this time we want the sentiment to be more specific, To do this, we provide one example in the prompt, clearly separating the input and output. Sending this to the completions endpoint and printing the result shows that the model accurately analyzed the statement, but that it didn't provide any more detail than when we used a zero-shot prompt. In more complex cases, one example is not enough, and we'll need to experiment to determine the number of shots the model needs for the use case. Let's extend the prompt to provide 3 examples. Running the same code again, we see that the model was much more specific. Hopefully you're now starting to grasp just how many problems can be solved using the OpenAI API, and how important prompts are to obtaining good results. Welcome back. In this video, we'll learn to unlock the chat capabilities from the OpenAI API, which underpin popular applications like ChatGPT. Let's get started. The chat completion endpoint allows us to have multi-turn conversations with a model, so we can build on our previous prompts depending on how the model responds. Additionally, chat models often perform just as well as completions models on single-turn tasks. Compared to the completions endpoint, chat completion allows for better customizability of the response through the use of roles, which we'll discuss in a moment. Finally, there's currently a substantial cost benefit to using chat models over completions. The cost benefit and flexibility of being able to have multi-turn conversations means that developers quite often choose a chat model when building applications on the OpenAI API. Roles are at the heart of how chat models function. There are 3 roles: the system, the user, and the assistant. The system role allows the user to specify a message to control the behavior of the assistant. For example, for a customer service chatbot, we could provide a system message stating that the assistant is a polite and helpful customer service assistant. The user provides an instruction to the assistant, and the assistant responds. One of the interesting things about chat models is that the user can also provide assistant messages. These are often utilized to provide examples to help the model better understand the user's desired response. We'll discuss multi-turn conversations in the next video. For now, we'll get familiar with using chat models for single-turn tasks. Making a request to the chat completion endpoint is very similar to the completions endpoint. Instead of calling the create method on the completion class, we call it on the chat completion class. There's also different models for these 2 endpoints. The main difference is in the way that prompts are provided. For the completions endpoint, the prompt is passed as a string for the model to complete. Due to the greater customizability of chat models through the use of roles, the prompt is provided in a different way. The prompt is set up by creating a list of dictionaries, where each dictionary provides content to one of the roles. The messages often start with the system role, followed by alternating user and assistant messages. The system role here instructs the assistant to act as a data science tutor that speaks concisely. Let's add these messages into the request code and print the response. Like the completions endpoint, we receive a JSON response, where the assistant's text response is nested inside the choices key. To extract the text, we use very similar dictionary and list subsetting as we did for the completions endpoint, except instead of the message being attached to a key called text, it is nested inside another dictionary inside the message key. To extract the text from the choices key at the top, we extract the value from the key with square brackets, which returns a list with a single element. Next, we'll subset the first element from that list, which returns a nested dictionary. Finally, we can access the content by subsetting the values from first the message key and then the content key. We can see that the assistant stayed true to the system message, only using 2 sentences in its concise explanation. In the next video, you'll learn how to extend this to multi-turn tasks But for now, time for some great work so far. In this video, we'll begin to unleash the full potential of chat models by creating multi-turn conversations. Recall that messages are sent to the chat completions endpoint as a list of dictionaries, where each dictionary provides content to a specific role from either system, user, or assistant. For single-turn tasks, no content is sent to the assistant role. The model relies only on its existing knowledge, the behaviors sent to the system role, and the instruction from the user. Providing assistant messages can be a simple way for developers to steer the model in the right direction without having to surface anything to end users. If we created a data science tutor application, we could provide a few examples of data science questions and answers that would be sent to the API along with the user's question. Let's improve our data science tutor by providing an example. Between the system message outlining the assistant's behavior and the user's question to answer, we'll add a user and assistant message to serve as an ideal example for the model. We add a user message containing a question on a similar topic, and a response that we consider ideally written for our use case. The model now not only has its pre-existing understanding, but also a working example to guide its response. With an example to work with, the assistant provides a succinct and accurate response that's more in line with our expectations. Another common use case for providing assistant messages is to store responses. Storing responses means that we can create a conversation history, which we can feed into the model to have back and forth conversations. This is exactly what goes on underneath AI chatbots like ChatGPT. To code a conversation, we'll need to create a system so that when a user message is sent and an assistant response is generated, they are fed back into the messages and stored to be sent with the next user message. Then, when a new user message is provided, the model has the context from the conversation history to draw from. This means that if we introduce ourselves in the first user message, then ask the model what our name is in the second, it should return the correct answer, as it has access to the conversation history. Let's start to code this in Python. We start by defining some base messages, which can include the system message and any other developer-written examples. Then we can define a list of questions. Here we ask why Python is so popular, and then ask it to summarize the response provided in one sentence, which requires context on the previous response. Because we want a response for each question, we start by looping over the user questions list. Next, to prepare the user message string for the API, we need to create a dictionary and add it to the list of messages using the list append method. We can now send the messages to the chat completion endpoint and store the response. We extract the assistant's message by subsetting from the API response, converting to a dictionary so it's in the correct format, then adding it to the messages list for the next iteration. Finally, we'll add two print statements so the output is a conversation between the user and assistant written as a script. We can see that we were successfully able to provide a follow-up correction to the model's response without having to repeat our question or the model's response. You've learned about the key functionality underpinning many AI-powered chatbots and assistants. Time to begin creating your own. Up to this point, we've used OpenAI's models for completing text in some way, whether that's answering questions, classifying statements, or editing text. In this chapter, we'll go further into the API's capabilities, including text moderation, audio transcription and translation, and even combining models together. Let's start with text moderation. Text moderation is the process of identifying text that is inappropriate for the context it is being used in. In online communities like social networks and chat rooms, moderation is crucial to prevent the exchange of harmful and offensive content. Traditionally, this moderation was done by hand, where a team of moderators flagged the content that breached usage rules, and more recently by algorithms that detected and flagged content containing particular words. Manual moderation is extremely time-consuming, and if multiple moderators are involved, introduces a subjective element that may result in inconsistencies. Word detection algorithms, although much quicker and able to run round the clock, can be a clumsy tool that misses some malicious content while accidentally flagging perfectly good content because it doesn't understand nuance or the context of the discussion. To prevent the misuse of their own models, Openai have developed moderation models to flag content that breaches their usage policies. The Openai moderation models can not only detect violations of their terms of use, but also differentiate the type of violation across different categories, including violence and hate speech. To create a request to the moderation's endpoint, we called the create method on openai.moderation and specified that we want the latest moderation model, which often performs the best. If a use case requires greater stability in classifications over time, we can also specify particular model versions. Next is the input, which is the content that the model will consider. This statement could easily be classed as violent by traditional moderation systems that worked by flagging particular keywords. Let's see what OpenAI's models make of it. Like other endpoints, the response is still a JSON and contains three useful indicators: categories, representing whether the model believed that the statement violated a particular category; category scores, an indicator of the model's confidence of a violation; and finally, flagged, whether it believes the terms of use have been violated in any way. Let's take a closer look at the category scores. The category scores are float values for each category, indicating the model's confidence of a violation. The scores can be between 0 and 1, and although higher values represent higher confidence, they should not be interpreted as probabilities. Notice from the small numbers, including in the violence category, that OpenAI's moderation model did not interpret the statement as containing violent content. The model used the rest of the sentence to interpret the context and accurately infer the statement's meaning. The beauty of having access to these category scores means that we don't have to depend on the final true-false results outputted by the model. We can instead test the model on data from our own particular use case and set our own thresholds based on the results. For some use cases, such as student communications in a school, strict thresholds may be chosen that flag more content, even if it means accidentally flagging some non-violations. The goal here would be to minimize the number of missed violations, so-called false negatives. Other use cases, such as communications in law enforcement, may use more lenient thresholds, so reports on crimes aren't accidentally flagged. Incorrectly flagging a crime report here would be an example of a false positive. Time for some Welcome back. We're now going to move away from OpenAI's text models to take a look at the functionality of their audio models. OpenAI's Whisper model has speech-to-text capabilities that can be used to create audio transcripts or translate audio from one language into an English transcript. The model supports many of the most common audio file formats, but does place a limit on the size of the audio file. Whisper has potential applications in automating business meeting transcripts and in accessibility features like caption generation. In this video, we'll discuss speech-to-text transcription. Let's use Whisper to transcribe a meeting recording stored in an MP3 audio file. The first thing we need to do is load the file into our Python environment. There are lots of Python libraries out there for working with audio files, but we'll be using the Python open function here. The open function takes two arguments. The first is the file to be opened, and the second indicates the mode with which the file should be opened. Different modes support reading and writing to virtually any file type. The RB here stands for read binary. All this means is that we're opening a file that is stored in binary format, which is typical for non-text files like audio, video, and images. if the audio file is found in a different directory to the Python script or notebook we're working in, we also need to prepend the file name with its path. This audio file can now be used like any other Python variable. Requests to the Whisper model are sent to the audio endpoint of the API. To create a transcribe request to this endpoint, we call the transcribe method on the audio class. Inside, we specify the audio model to use and the audio file to transcribe. Let's print the response to see what's returned. Like the other endpoints, we receive a JSON response, but fortunately, this response only contains a single key and value. We can access the transcript text using the text key. There we have it. The model did a solid job of transcribing the audio, but note that its performance may fluctuate with changes in audio quality or different accents. Sensitive or confidential audio should also not be sent to the model. Due to the Whisper model being trained on audio from non-English languages, it can also transcribe audio from many other languages with good results. The process for transcribing non-English audio is exactly the same. We open the audio file, make a transcribe request to the audio endpoint, and extract the text from the response. Time to create your own audio transcription. In this video, we'll discuss Whisper's translation capabilities. Let's dive right in. The Whisper model not only has the ability to transcribe audio into the language it's in, but also translate and transcribe audio in one go. This is currently limited to an English transcript, so we can translate and transcribe German into English, but not German into French. Like with its transcription functionality, Whisper can translate audio from most common audio file types up to a particular size limit. The process for translating and transcribing audio in one step is almost identical to normal transcription, with just one change. We open the non-English audio to translate and transcribe, which in this case is an M4A file. This is where the change comes in. Instead of using the transcribe method, we use the translate method, again making the request to the audio endpoint. The translated transcription can be extracted from the text key of the response. Looking at the transcript, we can see that it wasn't perfect, making 2 spelling errors. The performance of Whisper can vary wildly depending on audio quality, the language the audio is recorded in, and the model's knowledge of the subject matter. Before creating a full-fledged application on this model, we'll need to test that the model's performance is sufficiently good for the particular use case. Let's see how we can give Whisper a helping hand here. When we send our audio to the Whisper model, we can also provide an optional prompt. This prompt can be used to improve the quality of the response by providing an example of how we want the transcript to be styled. For example, if we want the transcript to retain filler words from the audio, like ums and ers, we can provide the following prompt along with the audio. If we know broadly what the topic of the audio is about, we can also provide this context as a prompt to help the model narrow down the correct words. Here's an example of a prompt to give the model more context. The transcribe method also supports prompts that can be used in very similar ways. Let's adapt our last request with a prompt to try and fix the spelling errors outputted by the model. Let's assume that we know this audio discusses AI trends and ChatGPT. We can define a prompt with this context and pass it to the prompt argument. Printing the response shows that with a little extra context, the model was able to accurately determine the correct spelling and style of the words. In this example, the original response was already pretty close to what we wanted, but for other cases, it's possible to see quite dramatic improvements using prompts. Time for you to try using AI to bridge language barriers. Welcome back. In this video, we'll take it up a gear and look at how we can combine models together. So far, when we've been using functionality from the Openai API, we've completed a task by passing an input to the model and receiving an output. This got us pretty far, from simple question answering to multi-turn conversations and audio translation. But what if we could do more with the model's output? Enter model chaining. Chaining is when models are combined by feeding the output from one model directly into another model as an input. We can chain multiple calls to the same model together, or use different models. If we chain two text models together, we can ask the model to perform a task in one call to the API, and send it back with an additional instruction. For example, let's say we draft an email template for a customer, and we want to validate the template follows some guidelines. We can send it back to the model with an instruction to check whether the guidelines are followed. We can also combine two different types of models, say the Whisper model into a text model, to perform tasks like summarizing discussion points and next steps from a meeting recording. Let's have a go at chaining Whisper with a chat model. Let's use Whisper to extract the attendees from a meeting recording, where we know it starts with introductions from each of the attendees. We start by opening the audio file and assigning it to audio_file. Next, we send the audio to the Whisper model and request a transcript with the transcribe method. To extract the transcript from the response, we extract the value from the text key. Now that we have the meeting transcript, we can use it to create a prompt for the chat model. The prompt starts with an instruction to extract the attendee names from the start of the transcript. Then we append the transcript to the end. We're now ready to send the prompt to the chat model. We create a request to the chat completion endpoint using the create method. Inside, we specify the model to use and the messages to send, which is just the prompt in this case. Finally, we extract the response from the chat model by digging into the nested JSON response. And there we have it. As with all of these models, there's no guarantee that the models will be 100% accurate. Whisper could make a mistake in the transcript, or the chat model may summarize incorrectly. It's important that any application of these models is well tested, iterating on the prompts if necessary, to understand its performance thresholds. Additionally, usage should be restricted to only non-sensitive data, as we may risk breaching data governance laws by unjustly exposing employee or customer data. Over to the final. Congratulations on making it to the end of the course. You've come a long way. In Chapter 1, you started to learn about the Openai API, what it's used for, how to create an API key for authentication, and how to make requests to the API via the completions endpoint. You also learned about creating and managing organizations, which you can use to mitigate rate limit risks and better manage usage and expenditure. In Chapter 2, you turned text completions up to the max and applied OpenAI's models to solve a range of tasks, including question answering, text transformation, content generation, sentiment analysis, and categorization. You even learned how to control the model's behavior by tweaking the max tokens and temperature parameters. From there, you unlocked the potential for multi-turn conversations using the chat completions endpoint, and created your very first AI chatbot. In Chapter 3, you explored OpenAI's moderation and audio functionality, and used these models to detect inappropriate content and translate and transcribe audio recordings. Finally, you brought everything together by chaining models together to start automating more complex tasks like creating meeting summaries. Congratulations again, and I hope you enjoyed learning all about this amazing functionality available through the OpenAI API. Have fun applying your newly learned skills.